Hi guys, welcome back to my channel. I hope you're all doing well. In this video we're going to do geographically weighted regression. We're going to learn how to do GWR, and that's what we do when we want to understand the spatial relationships between different variables. We want to understand how different factors affect one particular variable. And today I'm going to use data for 911 calls. We want to understand the various factors that affect the number of the 911 calls that happen. And so under the Arc toolbox, we are going to use the spatial statistics tools under modeling spatial relationships, and under that we are going to click on the geographically weighted regression. And here we are going to input our feature, which is the 911 calls. And so here, remember, we are trying to understand the factors that affect the 911 calls. That means that our dependent variable is going to be the calls. Sorry for that delay. Okay, so our dependent variable is the calls, and the explanatory variables, as I said in the previous video about the ordinary least squares regression, are the factors that affect the dependent variable. So they are like the predictors. They're the ones that we're trying to understand how they affect the number of calls. So here I'm going to use the population, the jobs, education, distance to the urban centers, the number of renters, alcoholics, and the income data. So let's specify our output feature class, and I'm going to store it under the regression as GWR calls, and under the additional parameters, let us specify the coefficient raster workspace where the output rasters are going to be stored. So I'm still going to store it under the regression. Okay, I'm going to change that. Okay, let's just change the location. You can just put it under data, and for the output cell size, that is the resolution of our rasters, you can just put it at 130. Then we click on OK. So as we wait for it to process, again, as I said, this is a regression where we try to understand how these factors relate spatially. We want to understand how these factors like the jobs, the population, the income affects the 911 calls. How do they explain it? If we want to predict the number of 911 calls that are going to happen in the future, we're trying to understand how these factors can help us. Can we use them to predict? Is this going to be a great model to use in the prediction? So the results of this regression is what is going to guide us. So let's check out the results. And as you can see, the current session is the geographically weighted regression. Still processing. So this is our results. Let's go to the messages, and under the messages we can see our results, and you can see here under the R squared adjusted value, you can see it's 0.85, and this means that these factors explain 85% of for the number of calls. They explain 85% of why the number of calls are that way. That's good. This means that this model is good. It means you can use it to predict the number of 911 calls. So let's check out the rest of the results. So let's start by seeing the residuals. So as you can see here, this map here shows the standard residuals. That is, it uses the standard deviation. That is the difference between the predicted number of 911 calls and the observed. And as you can see, it's random, which is good because it means it has considered all the factors. It means the model is not biased, and the red areas which have greater than 2.5 standard deviation means that there is a big difference between the predicted and the observed calls. So it is the over predicted areas, and the other areas, the blue areas, are the under predicted ones. And when we open this attribute table for the standard residuals, we can see that here we have the observed 911 calls that we had, and we have here the predicted 911 calls. So for the observed, like for this first polygon here, we have 6 number of calls, and the predicted is 70. And when you see the rest of the attribute table, you can be able to see the different coefficients for each factor. Remember, for the regression, we have the regression equation, and for each factor that is an explanatory variable, it has a coefficient, and that is what it uses to predict the predicted value. So for here, when you see this C1 pop, it means this is the coefficient for the population, while this one is for the jobs and the rest of the factors. So these are the coefficients that are used to predict the values, the predicted 911 calls. And so we can be able to visualize each of the intercept, the coefficient. So when we turn off the standard deviation residuals data, here we can see the raster for the intercept, and as you can see, this dark area here is where it has the low values, while here, which is almost white, it has the high values. And where it has the high values, it means it has more impact to the model. And this is the same case for the various other coefficients. For example, this one for the income, you can see how it is, and for each factor is different. You can see how the one for alcohol is different from the one for income, and this is for the one for the renters. Each factor affects the model in a different manner, which is how it's supposed to be, because it would be weird if they all affect it the same way. And if we want to visualize the predicted 911 calls, we can be able to do it here. Just under properties, you can, because now we are visualizing the standard residuals, we can change under the properties, under symbology, to see the predicted 911 calls. And so we'll be able to see the predicted ones, and we can also visualize the observed 911 calls, and then you can compare them. So here you can see we are visualizing now the standard residuals, and we have about 7 classes, and you can always change that. So let's visualize the predicted calls, and when we click apply, that's how it is, the predicted calls. And when we come here, we have the observed 911 calls. Let's also visualize the observed 911 calls. Okay, it's taking a long time to open, so let's go to quantities and let's put calls, put about 7 classes, and let's apply. So here, those are the observed 911 calls that we have currently, and when you turn it off and we open the predicted, that's the predicted 911 calls. So GWR, we can use it to model the spatial relationship. We try to understand how these factors relate, and as we've seen, these factors contribute to 85% of how 911 calls change, which is good. And besides that, we can use this model to predict the future number of calls, and so we've seen that you can be able to obtain the predicted number of calls. So that's what we can do with the GWR. We can model the relationship, and we can also predict how the calls will change in future. So that's basically how you do your geographically weighted regression. The first thing is to identify the factors that affect your variable. What are the factors that affect that particular aspect that you are trying to investigate? After you've decided which factors affect your variable that you're trying to investigate, you can now perform the geographically weighted regression, and from there you can be able to predict your values. You can predict whatever aspect you're trying to investigate. And so that's the end of this video. I hope that you've learned a lot, and thank you so much for watching.